So, question number 1. Oftentimes is missed. It's actually one of the easier ones, but you forget about common factoring. Common factoring, okay? So between the two terms, the common multiple is 4, because 4 divides into both 4 and 20, and they have a common x. So we just common factor out of 4x. If we pull out a 4x out of both terms, out of the first term we'd have left an x, and out of the second term we'd have a 5. That's it. Now if you need to recheck, you can just say, okay, well, 4x times x, 4x squared, 4 times 5 is 20. That is common factoring. We just find out their common multiple, and we find out how many x's they have in common. We just common factor out the 4x. Okay, example 2 is a trinomial, 2 sets of parentheses. We know x times x makes x squared. Multiples of 12, I'm going to use 3 and 4, but I need a negative 7, so I'm going to use a negative 3 and a negative 4. They're both negative because the negative times negative makes the positive, and if I add the negative 4 and negative 3, I get a negative 7. Okay? Example 3, 2 sets of parentheses. Now, the only way you're going to get a 5x squared is with a 5x and an x. Don't worry about the 3 yet, okay? The only way you're going to get a 2 is a 1 times a 2. Now we've got to be careful where we put the 1 and the 2, okay? I'm going to put the 2 here and the 1 here. I'm going to show you why. Now if you don't get it right, just switch them around. If you don't put them in the right place, switch them around. Now how do I know I've got to put them there? I do my double smiley. So my double smiley will have to make this negative 3 term. So if I have a 2x here and a 5x here, I'm getting close to 3. If this were a negative 5x and a 2x, I would get my negative 3x. Well, how am I going to get a negative 5? By making 5 times negative 1 and the 2 times a 1. That has to be the right answer. It will make 5x squared. The outside of the insert makes the negative 3x, and then you get the minus 2. Okay? Example 4 says solve. Example 4 is exactly like example 3. There's one small difference, and that is we have to do the solve. So first of all, let's bring over the 3x. Let's bring over the 2. Because we need it to equal 0. If we're going to solve, we need them always to equal 0. So I've got a 5x squared minus a 3x minus a 2 equals 0. Okay? Now, luckily, we already factored it. It's the exact same problem in example 3. We know, okay, it factors like this into a 5x and an x, positive 2, negative 1. And, you know, we already did this one. You can check the middle term with double smiley, but that's correct. But we're not done. We're not done because we're solving, okay? So for solving, we're going to set this first part, my 5x plus 2, and set it equal to 0, and my x minus 1 equal to 0, right? And I'm going to solve. Minus 2, 5x equal to a negative 2, divide by 5, x equals negative 2 fifths. Okay? Plus 1, x equals 1. Right, Alondra? We don't need to do that work because we already know, right? So, I mean, we can start skipping steps because you guys know exactly what happens, right? 2 answers. Great. We got 2 answers, okay? Example 5. When we take the square root, we have to remember 2 answers, okay? So I'm going to get the square root of 25 is plus or minus 5. Now the square root cancels the square, and you're just left with an x minus 4 equals the plus or minus 5. Now to get 2 answers, I'm going to have to break this up into 2 little mini equations. I'm going to rewrite it as an x minus 4 equals 5, and I'll put an x minus 4 equals a negative 5, right? Here's my plus 5, my minus. Plus 4, one answer is 9. Plus 4, the other answer is negative 1. How am I doing? Am I going too fast or am I okay? Everybody okay? Yeah. Okay. All right, example 6. It's similar, but let's bring the 4 over first, okay? So we'll have an x minus 1 squared equals negative 4. Now already before I do anything, I know I'm going to have an I answer. I will have an I answer because I'm going to take the square root of a negative, right? I will have an I. So let's do that. Let's take the square root. We will get an I answer. Square root, x minus 1 equals plus or minus 2i, because the square root of 4 is 2, and we get the square root of a negative number, which is I. Now, I'm going to add the 1, but when I add the 1, I will not really be able to add. I'm going to go plus 1. I'll get 1 plus or minus 2i. I can't add those because that's real, and those are imaginaries. That's my answer. Okay, example 7 and example 8. Let's look at these two carefully, all right? They're totally different questions. Example 8 has a y in it. So we're going to do example 8 on the x, y plane, okay? We're going to graph it. We can let the calculator do the work for us, and we're going to shade above, okay? Example 7 does not have a y, so we're going to do it on a number line. Okay, there's the difference. This one does not have a y variable, so we do it on a number line. This one does have a y variable, so we do it on the xy plane. So first of all, for number 7, I need to find my border points, okay? My border points come from factoring, okay? Factor. If I put a 1 right here, it's going to help me with my factoring. I'm going to go -6 and positive 5, because that will make a -1. But we all know, right, that it's the border points are going to be the opposites. So I'm going to have an x equals 6, x equals -5, 5, positive 6. Okay. Now, if you're listening to what I told Will, we could graph it, but what I told Will is if it's less than, we always shade in between. Okay. I'm going to have an open circle, though. Open circle, and because it's less than, I shade in between. It'll always work that way. And there it is. Unless it's a -x squared, but I won't do those. I won't give you one of those, okay? So in interval notation, if you're asked to do this in interval notation, I'd use a bracket if it's a solid dot, but it's not. So I use a parentheses, -5, comma 6, parentheses. Okay, it looks like a point, but in interval notation, that's what it is, okay? Okay, number 8. So 8, I can use my calculator. The window I'm going to use probably is going to go -10 to 10. But I'm going to go on this one maybe all the way down to -12. Does that make sense on my window? So maybe I'll go a little bit further. I know -12, so maybe I'll go -15 to 10. Okay, so my window, I'm going to be smart about my window. -10 to 10. I'm going to go all the way down to -15 because of this -12 and 10. So then I'm going to go ahead and get my calculator out. Fix my window first, -10 to 10. I'm going to go -15 to 10. Y equals, and then I'll put in my x squared, subtract 4x, subtract 12, okay, 12. I'm going to graph it. Alright, nice, there it is. So I do know it goes through 1, 2, I can see that from the calculator, right? Oh, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's got a vertex. Let's do my trace button. Looks like the vertex is down at about, maybe 2 and -16. And I don't have to be perfect on this. You do not have to be perfect on your drawings. You just have to get the right shape, pretty much in the right place. It does not have to be perfect. Now, I'm going to do a dashed parabola. It's going to be dashed because there's no equal sign there. So when I get ready to do this one, I'm going to go, okay, I got to make this a dash, and I can't just draw my parabola. I'm going to go like this. Boom, 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 boom. Dashed because it's going to be greater than the parabola, but not equal to, okay? Now to be greater than, we're going to go everything above it, right? So everything above it, above the parabola is actually inside, but don't use the word inside. Use the word above, okay? Don't use the word inside, use the word above, okay? Alright, how am I doing? Yeah. Don't worry about Liam, he's all good. Now, I'm going to need some room, so I'm probably going to have to do this one on a separate sheet of paper. Okay, so I'm going to do my quadratic formula. 2x squared minus 4x plus 7 equals 0, okay? So, A is 2, B is -4, C is 7. I'm going to use my negative b plus minus square root of b squared minus 4ac all over 2a. Okay? Alright. I'm going to go ahead and negative 4 plus or minus negative 4 squared minus 4 times 2 times 7 all over 2 times 2. And I'll back up and let you see what I've done, okay? There's my quadratic formula. A, B, and C. Did my negative B, negative 4, plus minus negative 4 squared, minus 4, and the 4 comes from the formula, times A, which is 2, C, which is 7, all over 2 times 2, okay? All right, let's keep simplifying this. Negative is positive 4, plus or minus the square root of 16 minus 56 all over 4. Simplify. 4 plus or minus the square root of negative 40 all over 4. Okay? Okay, I'm going to get an I. I will get an I value because of the negative here, but I'm going to break down the 40. So I'm going to go 4 plus or minus. Now let's see, 40. How about 4 times 10 and my I? And you know where my I came from? The square root of a negative number, right? All over 4, okay? How am I doing? What's that? I sure can, Micaiah. So, 4 plus or minus 2 square roots of 10 I over 4. Okay? Almost done. And you will get credit tomorrow for showing work on this one. If you don't show work on this one, you'll lose a point, okay? So now I'm going to have 4 over 4 plus or minus 2 over 4 square roots of 10i. I broke it up into 2 fractions. Okay? Okay? So 4 over 4 is 1 plus or minus 1/2 square roots of 10 I. There it is. Do you need shot? Oh, come on. Okay, how's that? So, you know what, Becca? You can go 1 plus or minus the square root of 10 over 2. Yes, same answer, okay? Same answer. Yes, you can. Yeah, make it quick. Okay? You ready to turn the page? Turn the page. All right? Okay, example 10. We are going to use our stats. Okay? We're going to use our stats. You guys ready?
Yes.
This is not hard. X's and Y's. Okay? So, in my calculator, okay? You ready? We're going to go to stat. Okay, we're going to go to stat. We want to go to edit. So I already did this for the first period, okay? Or second period. And I just put in my list, come on, glare. There you go. In my list, I put the 1, 2, 4, 6, and 7. I put in those for list 1, right? The X's go into list 1. And then I put in the 7, 4, 2, 5, 10, and for the Y's, which are list 2, okay? So go ahead and put those in. So we're going to go ahead and enter data, and that's under edit, right? So go to edit, enter data. Then we're going to go back to stat, and we want to calculate. But we want to calculate the quad reg. We need the quadratic regression, okay? So I push enter. And now I need to tell it what two lists I'm using, okay? It needs to know what list I'm using. So I can go list 1, comma, list 2, right? And I push enter, and there's my answer. I got to put my answer, though, where it belongs. This is A. The 0.738 goes there. The negative 5.48 is B. It goes there. The 11.88 C goes there. So we're just going to rewrite this as a y equals a 0.738x squared minus a 5.48x plus an 11.88. That's my quadratic model. So when you see the word model, an equation models the data. Does that make sense? That's why they call it a model, because the equation will model the data, okay? Now, find the vertex, okay? So to find the vertex, we need to use negative b over 2a, all right? So my a is my 0.738. My b is my negative 5.48. So I'm going to go a negative 5.48 divided by a 2 times a 0.738. I'm going to let my calculator do that work because, you know, that's just no way am I going to do it. So I'm going to go 5.48 divided by 2 times my 0.738. So I get an answer of about 3.7. So the vertex is about a 3.7 something, right? I need the something. How do I get the something? Yeah. Oh, sorry, you guys. Scoot over. So I got a 3.7 for the vertex. How do I get the corresponding y value? Say it. You say it. Becca, you said it right. Plug it in, right? So I'm going to go and plug it in. I'm going to go then my y equals my 0.738 times my 3.7 squared minus my 5.48 times 3.7 plus 11.88. Sorry, it's getting squished in there. Okay? I'm going to let my calculator do the work for me, right? Because that's like a lot of work without it. 0.738 times my 3.7 squared. 5.48 times my 3.7 plus my 11.88, and I get an answer of about 1.7. So that's my vertex. So it's the same stuff we've been doing. Don't let this be too hard for you, okay? How did we find the vertex before? As always, you use the same equation. Negative b over 2a, right? Using the same equation, right? When we got the vertex, how do we get its corresponding y value? Just plugged in, okay? So it's the same stuff we've been doing, right? Negative b over 2a, and then plug it, okay? Now, f of 3. Well, plug it in. F of 3 is just going to be a y equal a 0.738 times 3 squared plus, minus 5.48 times 3 plus 11.88. And again, I'm going to use my calculator. That's too much work for me to do. So I'm going to go 0.738 times 3 squared, right? Minus 5.48 times 3 plus 11.88, and I get an answer about 2.08. Okay, so this stuff's not that hard. It's stuff we've done before. We just have to make the formula, but to make the formula, we let the calculator do it for us, right? We use the quad reg. Yes,
Are you gonna make one like this with this hard of numbers?
yeah, we can, because we got calculus, right? We can do hard numbers because we got calculus.
Where did you get the 3 for the y equals?
Here?
Oh, okay. Well,
Yeah, it's a question. Good. Yeah. Okay, now 11. Here comes the easy stuff. All right, really, honestly, here comes the easiest stuff. In fact, number 14 is the easiest of them all. So 11, we're going to subtract. So watch. 2 subtract 4, right? So I'm just going 2 subtract 4, which is a negative 2. And I'm doing i's. I'm going to go 3i minus a negative 5i, right? So 3i minus a minus, which is really like 3i plus, which is a positive 8i. So I'm just adding reals. So I went this minus this. I went 2 minus 4. And I went negative 3i. I'm sorry. 3i minus a minus 5i, which makes an 8i. Okay? That's all you got to do. Okay, 12. Huh? What? Alondra, say that again. I'm sorry, I didn't hear. Are you sure?
Yeah.
Okay. Now, before I do 12, on the side, I squared is negative 1. Okay, I'm going to circle that. Okay? I squared is negative 1. I need to know that. So, here we go. This times this, I'll give this to you, Caitlin, when I'm done, is 10. This times this, positive 4i. This times this, negative 15i. And this times this, negative 6i squared. Alright? So I just FOILed it. I'm going to turn my I squared into a negative 1. I'm going to add, or actually subtract, these two I terms because they're the same. I'll go 10 minus an 11i minus 6 times negative 1. 10 minus 11i plus 6. 16 minus 11i. 13. We're almost done. Can't have I in the denominator, so we multiply both top and bottom by I. So I'm just going to go I over I. Let's see how that helps. So I'm going to distribute. I'll get a 3i minus a 2i squared over a 4i squared. Okay? So now, shift it over. What's I squared? Negative 1. So let's change I squareds into negative 1. So I'm going to write it as a 3i minus 2 times a negative 1 over a 4 times a negative 1. Okay? How am I doing? I'll have a 3i plus 2 over negative 4. And I would take that answer. A better answer really is going to be this. 2 over negative 4 plus 3 over negative 4i, or negative 1/2 minus 3/4 I. That's the answer I really want. If you gave me this one, I would give it to you because you did all the stuff right. I's out of the denominator. But that's the best answer, okay? I mean, I just reduced. Okay. 14. Easiest problem on the test. Seriously. Reals, imaginaries. Okay? 1, 2, 3. 1, 2, 3, 4. There's your point. Right there. That was hard, huh?
Yeah.
Don't miss that one. I'm going to be really sad for you if you miss that one, okay? Okay, now finally, the absolute value is basically Pythagorean's theorem. It is Pythagorean's theorem because we want to really find what we're looking for is the length right here. That's what the absolute value is, the length from the origin out to the point. So it is just going to be the square root of 3 squared plus a negative 4 squared, which is the square root of 9 plus 16, square root of 25, and like Michaela said, no, just plain old 5. Just 5, right? Square root of 25 is just 5, okay? Alright, that is it. Alright, that is it. We can